Let's get started on Module 2, Introduction to Virtualization. In this module, we will ask the questions, what is virtualization, why do we use virtualization, and what are the components of a virtual network infrastructure. The module is broken into 3 lessons: Introduction, User Interfaces, and an overview of ESX. Let's get started on Lesson 1, Introduction to Virtualization. Virtualization is the foundation of cloud computing. Cloud computing means computing across the internet. A typical example would be a user uses his laptop computer or his smartphone to connect across the internet to a cloud server, and the applications run on the cloud server. VMware provides the software that runs the cloud server. Virtualization is the foundation of cloud computing, and VMware vSphere runs the cloud servers. VMware vSphere runs the cloud servers. The name of the company is VMware, and the software is called vSphere. Let's now look at the difference between a public and a private cloud, and another way to phrase it is public versus private data center. And the question is, do you use your own data center or do you use someone else's data center? Here at the Community College of Baltimore County, we own our own data center. We manage the hosts and the virtual machines. We do the backups. We upgrade the servers. We maintain the uninterruptible power supplies. Our employees can connect locally or remotely, and our students can connect remotely. And the advantage of having our own private cloud or our own data center is that we get total control over our network. And of course, the disadvantage is the cost, the time, and the labor, and all the people it takes. We have 80 employees here at CCBC on the IT staff, and their job is to maintain all of our campuses. Now, a public cloud is where you store your data on somebody else's data center. If you take an example of a 3-lawyer lawyer's office, they would not have the time or the expertise to manage and maintain their own servers. Most likely they would outsource. And a typical example is that they would not have their own web server. They would put their web page on a public cloud, for example, GoDaddy.com. And the advantage there is they wouldn't be responsible for power management, for doing backups, or for upgrading the servers. At CCBC, we have a hybrid cloud. Most of our applications and servers do run on our own data center. However, we do have some applications that run on public cloud servers. But whether it's a private or a public cloud, VMware vSphere runs the cloud servers. Let's look at physical and virtual architectures. We will ask the question, what is virtualization and why use it? Before we look at virtualization, let's look at non-virtualization. Let's look at the traditional physical servers, whereby you have traditional architecture, traditional server-based network, whereby we have multiple separate servers. In a traditional server-based network, the users connect to the workstations, which connect to a switch, which connect to another switch, which is in the server room at the data center. There is a separate file server, an application server, and a domain controller. Each server is on a separate physical machine. That's the typical way, traditional way of doing it. The disadvantage of the traditional method, the server-based method, is an inefficient utilization of resources. When we first started our data center here at CCBC a long time ago, before they had virtualization, we got 4 servers, 4 new servers, each had 4 CPU, each had 8 gig of RAM, and that was a lot at the time. And one was going to be the DNS server, one was going to be the DHCP server, one was going to be the file server, and one was going to be the registration server. So when we installed all of the operating systems and applications, we found out that the DNS server and the DHCP server were only at 25% utilization, which is a total waste of CPUs just sitting there doing nothing. And conversely, the file server and the registration server were totally maxed out. This is called an inefficient allocation of resources, whereby some servers are totally maxed out and other servers are only operating at 25% of capacity. So the solution was virtualization. What we did is we got one big server and we installed multiple server operating systems on that one big server. We got an IBM Blade server, which is a big old server with 64 processors, and this thing that looks like a lunch tray is one of the 32 blades. And if you pull it out and look at it, you can see a blade is a circuit board which has 2 microprocessors and 2 gig of RAM. A blade is like a motherboard, and you know what a motherboard is. It's a circuit board with a microprocessor and RAM. So each blade is almost like a motherboard. And when you have 32 blades in one server, that gives you 64 processors. It's just like having 32 motherboards. Of course, here at CCBC, when we bought it, we bought the rack, and we only put 4 blades in it initially because they're $4,000 per blade, and then we got more later as necessary. And then, to implement server virtualization, we installed the multiple server operating systems on the one big blade server. The ESXi Hypervisor is software that allows the blade server to host multiple operating systems. VMware makes the ESXi Hypervisor. So when we say a computer is an ESXi host, it means it's a big computer such as a blade server which has the ESXi Hypervisor installed on it. Multiple machines run on the big old ESXi host, and to view the contents of the ESXi host, this is the vCenter Server vSphere client, which we will be using a lot in this course. And we can see in this data center on this one host, we have multiple virtual machines taking different amounts of CPU utilization and RAM. This diagram shows that you can have a single physical computer with multiple operating systems and applications running on that computer. And how can you do that? Well, that's what ESXi does. That's what VMware does. That's what virtualization is all about, allowing multiple virtual machines running multiple operating systems to run on the same one physical host. Since different servers have different requirements, we allocate different amounts of RAM and a different number of CPUs to each virtual machine. For example, we would allocate 1 CPU and 2 gig of RAM to the DHCP server. We might allocate 2 CPUs and 4 gig of RAM to the DNS server, 6 CPUs to the file server, and 7 CPUs to the registration server. Can you do that? Allocate 7 CPUs to a registration server? Well, yeah, that's one of the big advantages of virtualization. Multiple virtual machines run on the ESXi host, and each server is assigned a different number of CPUs, amount of RAM, and disk space, and the reason we do it is for efficient resource allocation. If we compare the traditional server-based network infrastructure to a virtual network infrastructure, we will see in the traditional method we have some servers which are totally maxed out and other servers which are only operating at 25% of utilization. But in a virtual network infrastructure, we have multiple virtual machines running on one big old ESXi host, and they're assigned different numbers of CPUs are allocated to each virtual machine as necessary. Additional advantages of virtualization include consolidation, power savings, and ease of upgrading. This is what our server room looked like a long time ago. Because every time you add a new server, you got to add a power cable and an Ethernet cable and a keyboard cable and a monitor cable. But with virtualization, you are consolidating many servers to one physical server. Eliminates server sprawl, reduces power consumption since there's only one cable coming into it and one Ethernet cable and one power cable. It implements cabling consolidation, and it's easier to upgrade by just adding additional blades. And you remember what a blade is. It's the lunch tray. There are other advantages of virtualization as well, such as speed of provisioning and agility, which we will cover later in the course. Let's now briefly look at storage area networks and virtual disks. What's the difference between a physical architecture and a virtual storage architecture? In the traditional local area network, the disks were in the servers. The users connected to the switches, which connected to the servers, and each server might have 2 disks. If I wanted 3 disks to be in the first server, well, I guess I could turn them all off and pull the disk out of the first server and move it to the next. That would be a lot of trouble. Or maybe I only wanted half of a disk in the first server, and I couldn't do that at all. And they can't access each other's hard disks easily either. So what we do is we implement a storage area network, and to make a storage area network, you get an external disk array, and you take the disks out of the servers and you put them in an external disk array, and then the servers can save the data to the disk array, and one server might use 4 disks of capacity, one server might only use a half a disk of capacity. The local area network, you already know what that is, and that can be 100 meters across. But a storage area network is a much smaller area, like 10 feet across. It's going to be in the same room. The difference between a storage area network and a production network: in a production network carries traffic from users to virtual machines on the ESXi host. But in a storage area network, it carries data from the virtual machines to the disk array. In a storage area network, the virtual machines save their data to virtual disks on the disk array. Virtual disks. Now, as we will see later in this course, we will look at the concept of encapsulation. Encapsulation describes the virtualization of a hard disk. The virtualization of a hard disk is called encapsulation. A virtual hard disk is a single file which is saved to a file system. You're probably familiar with the Windows NTFS file system and the Unix Linux NFS file system. Well, VMware has the VMFS, the virtual machine file system, which spans multiple disk arrays. A VMFS Datastore is a logical volume which spans multiple disks. So, a virtual machine saves files to a virtual hard disk, which is a file on the VMFS Datastore, which is stored on the SAN hard disk. And that is a lot. I know that's a lot, and we will cover all of this a lot slower and in greater detail in Chapter 6. Physical and virtual networking. Let's compare physical architecture versus virtual architecture. Now, I know you're familiar with a virtual switch. Virtual switches connect servers to servers and PCs to servers and everybody to the uplink, which connects to the router, which is the internet connection. That's a physical switch. Well, a virtual switch does the same thing. It connects virtual machines to virtual machines, and it connects virtual machines to the network interface card in the ESXi host. Here's the example. We've got a big old ESXi host, and this big box right here is supposed to be the ESXi host. Running in the ESXi host, you have virtual machines, which might contain Windows 2003 server, Windows 2008 server, Active Directory, domain controller, file server, web server. And the ESXi host would have a network interface card, and that network interface card connects to the physical switch, which connects to the users at their PCs, and it connects to the internet. So the question is, how do these multiple virtual machines with different operating systems all connect to the one single physical switch? And the answer is a virtual switch. Virtual switch is a piece of software that connects virtual machines to virtual machines and connects virtual machines to the physical network interface card, which connects to the switch, which connects to the users and the internet connection. You might have multiple virtual switches. This diagram shows a single virtual switch, but you might have multiple virtual switches if you had multiple network interface cards on your ESXi hosts and separate networks. For example, here at CCBC, we have two separate networks, the student network and the administration network. And this shows that this ESXi host has one network card which goes to one network, and this virtual switch connects these virtual machines to this physical switch. And then we have another external physical switch which is plugged into a different network interface card in the ESXi host, and that virtual switch connects these virtual machines to this network. So you can see the virtual machines on the left are connected to a separate network from the virtual machines on the right. Virtual machines connect, virtual switches connect virtual machines to virtual machines, and they connect virtual machines to the physical network interface card on the ESXi host. Virtual machines will be covered in greater detail, and then that is a lot. That's a lot. Virtual machines will be covered in greater detail in Module 5. So, virtualization summary, not the whole chapter, just the virtualization summary. Whereas in a traditional server-based network infrastructure, we have separate physical servers, the disks are in the servers, and we have separate physical switches connecting them all together. In a virtual network infrastructure, virtual machines, we have virtual machines, which run on an ESXi host, virtual disks, which are stored on a storage area network, and virtual switches, which connect virtual machines to the ESXi host network interface card. Now let's move on to lessons 2 and 3, which we do at the same time because there's so much overlap. In this section, we are going to look at an ESXi host and what are the methods of configuring, and what are the 3 methods of configuring an ESXi host. Direct user, and we will look at methods of configuring the ESXi host. Direct console user interface, vSphere client, vSphere web client. What is an ESXi host? Well, I think everybody knows what an ESXi host is. It's a big old computer which has multiple virtual machines running on it. An ESXi host contains the ESXi software, which allows multiple virtual machines to run on that one ESXi host. A data center might have multiple ESXi. A data center might have multiple ESXi hosts. A data center might have multiple ESXi hosts. Now let's look at ESXi host configuration. You can do it locally or you can do it remotely. You will be doing it mostly remotely, but you will do some local configuration. So let's look at local configuration first. Local configuration is where you walk up to that ESXi host and you configure it while standing at the ESXi host as opposed to remotely. And one thing, the most common thing you're going to configure on the ESXi host is going to be the IP address. So to do that, let's bring up the screen for the ESXi host, and they call this the Direct Console User Interface. So this is the ESXi host. We press F2 to get started, and then we have to type a username, and the administrator name is called root. And the password, click on enter. Then we select Configure Network Management, and then we select IP configuration, and then we type in the IP address and the subnet mask and the default gateway, followed by enter, escape, and escape. And that's about all you would do locally, configuring the ESXi host locally. Most configuration is going to be done remotely using the vSphere client. The vSphere client is a piece of software that you install on your Windows 7 workstation, and it allows you to connect to and configure an ESXi host and the virtual machines which are on the ESXi host. It allows you to create, delete, manage, modify virtual machines on the ESXi host without walking up to the ESXi host. To install vSphere client installation, we attach to the ESXi host. We go to the Internet Explorer and we type in the IP address of the ESXi host. How do we know the IP address? Well, we just walked up to it physically and typed it in. And then when we connect to it, we can click on download the vSphere client. We download the vSphere client and we install it on our computer, on our workstation locally. And then after we install it, we will see there's an icon. We click on the icon for the vSphere client. We type in the IP address of the ESXi host, and notice the administrator name is called root. Click on log in, and we are now connected to the ESXi host using the vSphere client. We are connected to the ESXi host. And they give us a little description. A host is a computer that uses virtualization software. If we click on Summary, we can see that this is a Hewlett-Packard computer. If we click on Virtual Machines, we can see that 5 virtual machines are on this computer. 4 of them are running, and one is taking a lot of processor utilization. The others are just taking a little bit of processor utilization. Resource allocation will show the distribution of resources, which we will go into in greater detail in Chapter 10. Performance shows how hard this ESXi host is working, and you can see it's not working very hard at all. Configuration, we will be working a lot with the configuration later. Shows the processors we have, memory, storage, networking. Local users and groups shows who can log on. Events show any error messages or any events that occurred, such as when somebody logged on or logged off. Permissions says who has the power to do what. And on the far right, there is a tab called Map. And this shows a map of this small vSphere network that shows 2 ESXi hosts, a couple virtual machines, and 2 storage area networks. What I will ask you to configure in your exercise is some real simple ESXi host configuration stuff. License, time, and DNS. So if I go into the tab that says configuration and I select license feature, you can install it without a license. So what you do is, as a student, you'll be installing it without a license, and then when you install it for the real thing, when you install it at work, you install it without the license. You reinstall as many times as it takes to get it working the right way. When you finally get it running the right way, then you enter the license key. Of course, you have to purchase that, and that costs a lot. But like I said, you can run without the license key for 60 days. And then you enter the license key. So I will just, you don't have to type in the license key, I just want you to look at this section here. And another variable is the time configuration. Of course, we do this on Windows workstations. I would just like you to go and set the time on the ESXi host, check the time and the date, and verify that the network time protocol is enabled. The network time protocol just makes this ESXi host sync up with the time server at the National Institute of Standards. And DNS and routing information. Here is where we get to specify the host name of this computer. By default, when you install it, it's called localhost, but you would give it some sort of name like ESXi1 or ESXi2. The name of the domain, such as ccbcmd.edu. And the IP address of the DNS servers. And then under routing, we would type in the IP address of the default gateway. On the upper left-hand corner, if you click on File, you can export system logs, which can be used for troubleshooting. The vSphere client is installed on your workstation, and it allows you to remotely configure the ESXi host. You usually don't have to walk up to the ESXi host. Most of it is done remotely. The vSphere web client. If you are hanging out at Starbucks, surfing the internet, drinking a cup of coffee, and something goes wrong at work, and you need to connect to the vSphere network at work, you can use the vSphere web client to connect to the ESXi host over the network. To install the vSphere web client is typically installed on a virtual machine on a server on the ESXi host, and it can be accessed from any computer with a browser. So you go to a server, which is typically installed on a virtual machine on the ESXi host, put in the install DV and select DVD and select install the VMware client. And we will do this in greater detail in Chapter 14. And then the user can connect to the ESXi host. The user logs in with the web client interface, and then this allows the user to access the vCenter server, to access virtual machines, to perform administrative tasks. This shows the virtual machines that are currently running on the ESXi host and the amount of processor utilization each one is taking. So there are several virtual machine interfaces, such as there are several methods of configuring the ESXi host. You can go up to the ESXi host using the direct user command line interface, the direct console user interface. You can use the vSphere client or the vSphere web client. Most of us use the graphical user interface, but you will find as you get into more advanced levels of computing, you use the command line more and more. So let's look at methods of managing the ESXi host from a remote command prompt. We have three different methods. One is the vSphere command line interface. This is an application that we install on a Windows or Linux computer. It's a set of command line tools which execute on the ESXi host. The vSphere Management Assistant is installed as a virtual appliance, and we will talk later as to what virtual appliances are, which is installed in a virtual machine. And it is a platform for multiple toolkits, such as the Software Developer Kit for Perl or application programming interfaces, which allow third parties to develop applications which can tie into vSphere, such as backup programs. And then if you know Windows PowerShell, the vSphere Power Command Line interface is additional commandlets that you can install as a snap-in into Windows PowerShell, and it's an automation tool, meaning it allows you to perform scripting. Multiple methods of configuring the ESXi host. Direct console user interface, vSphere client, web client, and the command prompt. Most of this course is going to be spent using the vSphere client. Different vSphere editions: Standard, Enterprise, and Enterprise Plus. If we go to VMware's web page, we can see there's their description of Standard, Enterprise, and Enterprise Plus. Standard, the description says, offers server consolidation. Standard is for a small business, and it offers server consolidation and business continuity. Enterprises implements load balancing, and Enterprise Plus implements application availability. If we compare the three, we will see that Standard does vMotion and high availability, data protection, fault tolerance, and virtual machines. But when it gets to be stuff like distributive resource power management or distributive resource scheduler, which we'll do in Chapter 11, that's not done by the Standard Edition, only by Enterprise and Enterprise Plus. And when we talk about distributed switches, that's only supported by Enterprise Plus, but we don't even do distributed switches in this class. And then they've got the vSphere Essentials for small, really small businesses with a maximum of 3 servers. The Essentials kit gives us the vSphere Hypervisor, and Essentials Plus has vSphere Hypervisor and vMotion high availability. If we look at the prices of these guys, we will see they go from $500 to $20,000 easy, because you're paying by CPU. So you got a machine with a lot of CPUs, you're paying even more. And on VMware's webpage, it shows how you can download a free trial, and it's the full-blown thing. Enterprise Plus, it'll allow you to do everything. It's good for 60 days, and they're hoping that you'll like it, and then we'll pay for the license key. Of course, as students, we just keep reinstalling it. Module 2 Summary. In this module, we discuss what is virtualization and why use virtualization. We went over the components of a virtual network infrastructure, which include vSphere, ESXi host virtual machines, storage area networks, virtual disks and VMFS datastores, virtual switches, methods of configuring ESXi, notably the vSphere client, and different editions of vSphere. Your lab is to install vSphere client if it's not already installed on your computer, and all I would like you to do is simply log on to an ESXi host, poke around, examine all the tabs, configuration, performance. We will use all the tabs throughout this class, and all I'm going to ask you to configure is the host name and domain name and then specify the time in the network time protocol. Otherwise, this concludes Module 2. Thank you very much, and have a nice day.